Good evening, my name is Philip Tanofsky and this is my final project for DATA608 Fall 2020. So my data visualization project is attempting to show kind of a socioeconomic breakdown of Austin, Texas, and attempt to identify where public resources are located and who kind of has access to that. The goal is to identify maybe kind of inequality of availability of public resources, and then just kind of overall socioeconomic breakdown of Austin City, a growing populous urban setting. So this is a Plotly Dash app deployed to Heroku and written in Python. So the first tab, Austin 2017, this was public data available from the county of Travis County in Austin, Texas. So I just pulled a bunch of Excel docs using a Python notebook, extracted it, and built a CSV, which I'm able to just pull as the application loads. So from that, as you can see, the choropleth is rendered given the two statistics by dropdown. So each dropdown has the same list of statistical options. So default, just total population, and then age 18 years and over. So let's select race, Black or African American, and then we will select a different value from the drop down, and we'll go with income 200,000 or more. So give it a moment and it re-renders. As you can see, just based on the legend here, the higher volume of statistic 1 would be the aqua turquoise, and so as you can see, East Austin. So for those not familiar, I-35 divides the city vertically, so into east and west. So with tooltips, you can see zip code and then the information for each statistic. And then as we move to the west side, you can see lower numbers of Black or African American, and yet higher volume of those households making greater than $200,000. So the opportunity there to kind of compare and contrast a couple of meaningful statistics for Austin across its 45 zip codes. So then in trying to identify the resources, didn't quite turn out as well as I'd hoped, but so I think the most interesting one is electric car charging stations. So give it a moment, it'll re-render with the markers on the bivariate choropleth, and as you can see, a lot of the charging stations more on the west side of Austin, so where those making more money, and then not necessarily where the higher volume of, say, Black or African American individuals are. So you can zoom in and out with the on the map. So scrolling down, given those two statistics, I just presented like a simple scatter plot. I thought it would be interesting to see what would be the shape of the data. Oftentimes, data science are looking for, kind of a linear pattern. Obviously, that's not the case here. So just kind of a straightforward presentation, and then you can hide or show it. So just hide it, and then below that, I present a univariate choropleth. So visualizations based off just single variables, and this was my attempt at small multiples. As you can see, not quite small, maybe medium multiples would be a better definition. So just presenting the different statistics individually to allow for kind of a visual comparison. As you can see, maybe get about 6 on the screen at once. So breakdown by total population, by race, the income ranges, and then at the end by occupants per room. I thought this would kind of be a good way to maybe understand where the more wealthier individuals live for those that live with occupants of less than 1 per room. And then on the second tab, Austin 2010s. So this data from the census, making an API call. So for each year, a single variable choropleth is presented. So very obviously very similar to the same map, but now it's just based on a single variable. In this case, just total population. And then you can play and pause the animation of watching it scroll through the years. So after pausing it, then you could just select a given year, say 2017, and after a moment it updates. So as you can see, zip code 78660 has the highest overall volume, or highest population. So, all right, that is my presentation. Thank you.